Hello everyone. Today we'll go for second experiment, that is flashing and running LED. And we go to project wizard, next. Make sure that this is 16F877A. Say next. Make sure that there are no red marks here. Here you simply browse and go to your main directory. My main directory is npm demo pick experiments, and in the main directory I'll create flashing running. So you can create a different one for different. Earlier I have created and made a video, but unfortunately it was not saved. So I am saving with different name, flashing LED 1. So I'll open. I'll give the name for project flashing LED. Save. So this is the project now that I have saved. Since I have already say the .asm file here, I can add it. If you wish, you can add any of the files if you have. Here you can add it. However, I just want to go through the regular procedure. I don't want to add it. I'll go to say next and finish. Go to file, open, or simply click on shortcut C drive. Since mine is 64-bit OS, I am going for program files x86, microchip, MPSM suite, template, code, search here 16F877A, temp.asm, open it. Immediately you do a next step, that is save as. Save it to your directory, that is your project directory, embedded system. This is my project directory. Save it with meaningful name and extension .asm. Save. I have a program that is there already, so I'm going to copy it and I'll paste it. You don't do this because you don't have subcopy. Make sure that these things will be there. In the configuration mode, this will be by default showing as RC. You change it to HS. This is the important thing that you have to do it. High speed crystal oscillator that we are using. Don't do anything here. Come to main program and type your program. Okay. At this point you can pause the video and you can look into the screen and you stop. You can type, or you can refer the previous journals and you can type the code, or already I have given the code to you in the classes and you can take up those codes. And I have to add this to source file and I have to build it. Make sure that there are no errors here. If there are any errors, you have to go to errors here and double click on the error. It will take you to the particular line and you have to clear the error. Next thing, you can able to debug it using inbuilt debugger. That is, before that, the debugger, if you want to do it, make a simple thing is this call delay. You simply make comments, or else you will enter into this while doing step operations, and this loop is 256 into 256 times. So you have to hit so many times steps, so that is not suitable. So simply comment this and then build again, and then go to debugger, select tool, select MPLAB sim, and I want to see the flashing at port D, so I'll go for special function register. I'll look at this point after executing this. So I am executing this. So initially I am trying to make port D as output port. Then once I'll send FF, another time I'll send 00. This is a simple program. Now if you keep observing at this point, this is quite easy program. Now it will become FF, and after 2-3 instructions it will become 00, and this will repeat FF 00. So this is what flashing. If you don't want to comment this, there is other option called as step over. Okay, now it is in this, you can able to see the pointer. This is going to be executed this time. Okay, step into is okay. I'll build it again. It will be easy. And I am going for step into. Now it will become it became FF. And when you get call delay instruction, I don't want this to be executed because it will take me to this loop, which is very long. So I am going to step over the second one you have to hit. If you don't want to comment call delay, it will take you out. And then again step into. Okay, now it became 00. I don't want to execute call delay. I just say step over, and it will come out of this. And next thing again it will be the same loop continues. So this is the simplest one, and how we can able to build it using Proteus we can able to see now. We'll go to parts, pick 16F877A. You just type it as it is and you are going to get the same device, and you want LED. Simply search with LED. We have red LEDs, so I am searching for LED red, this one. You can take any other LED. So for simplicity I am not going to design a resistor. Actually there will be a resistor, depends on the LED color also, the resistor value will be different. At this point I am trying to make it as simple as, so I don't want to connect resistor and I don't want to calculate the resistor value. I am simply connecting without any resistor. So I want to rotate this, which is quite possible. Using simply hit plus, it will rotate. And then go on placing the LEDs. Okay, LED 4, LED 5, LED 6, LED 7 and LED 8. So you have to connect it to port D because in the lab these things are connected to port D. Okay. You can connect in any way that you wish. And these things must be connected to ground. So ground, I will find it here, click here, go to ground, and you can have a common ground if you wish. You can connect it here itself. Things work, but what I am not showing is resistor, which is required to limit the current, or else it will drain the microcontroller current. And right click on this, edit properties, make it 10 megahertz because in the lab we are using 10 megahertz. Browse your hex file. So So this is the hex file. Okay, and simply run. After that you should be able to get this flashing action. This is how simple it is. At this point I am going to pause it and we'll go for running LED. So I'll close it. You have to take a new project actually. Go again and start new project and do running LED, this everything, but for simplicity I am doing it in this, but don't do it yourself. So you take new project, again start with a new project and everything new. For simplicity I am connecting here itself. I'll add the earlier program. I am going to show you the program now. You can pause the video and you can take up this code. This is very simple. This is the code, okay, which is very simple, and you can change many things here. So now I did RLF. You can do RRF. Instead of 80 you can take 1, 2, 4, 8, 1, 0, 2, 0, 4, 0 or 8, 0, anyone. All are going to work. So I'll simply build it. And you can able to see the action because everything is ready. You can able to see the running LED action here now after doing this. It is how simple. Okay, so hope you can able to do this experiment easily at your home and save this. Don't simply ignore it, save it, and save it in the same location that you are doing it. So you save in the same directory that you saved your program. Okay, I think this is sufficient for you. So program already I have shown. This is the program for running LED. Delay program is common, which is as similar to that of the earlier one. I'll stop at this point.